Welcome back student. Assalamualaikum warahmatullahi wabarakatuh. Harap semua dapat berpuasa dengan baik kali ini. Alhamdulillah. Saya record ni pada waktu malam. Sebab apa waktu siang-siang ni suaranya lebih syahdu lagi. Mungkin sebab tak makan. Tapi last week saya record waktu siang. So okay je. Alright. This is a very short part, which is basically prerequisite to the range and endurance. Okay, it is about fuel consumption. Okay, so let me get this into full screen mode so that you can take a look at it. Okay, now for jet aircraft, specifically for turbojet, turbofan, or ramjet. The fuel consumption is measured as thrust-specific fuel consumption, or TSFC. Okay. Sometimes people write it as TSFC or simply C or C subscript T. Okay. T referred to the thrust. The definition is that it is the weight of fuel consumed per unit thrust per hour. Okay, so the weight of fuel in Newton, okay, the unit will be in Newton, the weight of fuel, okay, the unit of thrust is also Newton, okay, so it's Newton of fuel per Newton of thrust per hour. So Newton divided by Newton will become 1. So the unit is basically 1 over hour. Or if you prefer to use unit pound, it will be pound of fuel per pound of thrust per hour. So 1 per hour. Now, meaning that if you get for example, the TSFC, you can use Newton or you can use pound, it doesn't matter. It is the same. Okay, because in the end it will become 1 per hour. So few types of fuel that is usually available, okay, for turbojet or turbofan engine, for example, kerosene, jet A1 or diesel. Okay, we have propulsion lab, and there are 4 jet engines there, and you can either use kerosene or diesel, and the specific density of this is around 0.6 to 0.7. I say this is specific density, meaning that it is with respect to water, meaning that it's between 0.6 or 60% to 70% of the density of water. Now that is for jet aircraft. For propeller aircraft, either turboprop or reciprocal engine, since the measurement of the fuel, since it is rated at horsepower or kilowatt, okay, in other words, power. So we're going to use PSFC or power specific fuel consumption. Okay, PSFC, or some they use CP. Okay, some books they use CP. It is a definition. This definition is the weight of fuel consumed per unit power per hour. Okay, so in SI unit we can use the Newton. Okay, the weight of fuel in Newton per kilowatt of power per hour, or Newton per kilowatt hour. Or if you use imperial system, that will be pound of fuel per horsepower of power per hour, or pound per horsepower hour. Now these two, they have different units. So for PSFC, you have to be sure which unit. Okay, the question or the book or the problem is doing, the engine is using. Okay, if you get a number, for example 0.05, okay, PFFC, so in what unit But for truss, it doesn't matter. You can use both imperial unit or metric unit, or as long as that means 0.05 Newton of fuel per Newton of thrust per hour, or 0.05 pound of fuel per pound of thrust per hour. They are both the same. But 0.5 Newton per kilowatt hour and 0.5 pound per horsepower hour is not the same. It's not the same. Now, there are various fuel type they use. For turboprop, you will use kerosene, okay, Jet A1 or JP kind of engine, per kerosene type. But for reciprocal engine, can either use petrol or diesel engine. Some aircraft use diesel, okay, diesel fuel, okay, with a specific density around the same. Even the kerosene is also around this 0.6 to 0.8. It depend on the density, depend on type of fuel. Okay, this is how we quote the specific fuel consumption. Okay, for engine that uses thrust as its power rating, or its thrust rating, or for engine that uses power as a power rating. Now, for aircraft, okay, electric aircraft will use electric motor. Okay, it can either powered by battery or powered by solar or other kind of, for example, a hybrid system. There is a IC engine inside. That IC engine is only used to generate electricity to power up the electric motor. So the electric motor will run the propeller or ducted fan. Okay. In this case, okay, uh, the consumption we consume the current or voltage. Okay, so can either current consumption for fixed voltage, or we can use a power consume. Okay, the power consumption. So electrical power. So take note that electrical current is actually electrical charge per time or coulomb per second, and P is the power consumed. So for current, the unit is ampere. For power, the unit is in watt or kilowatt. Okay. Now, battery usually stores energy, and battery is quoted in milliampere hour or ampere hour. Now, I'm talking about small UAV that uses battery. Okay. So quoted in milliampere hour. So milliampere hour, that unit is actually the capacity of the battery. Okay, it's like how many liters of fuel that you have. Okay, and if you quote in milliampere hour of that battery, you must also quote the voltage. Okay, so for example, 5,000 milliampere hour for 3-cell battery or 11.1 volt battery is not the same with 5,000 milliampere hour with single cell battery or 3.7 voltage, 3.7 volt. They are not the same capacity. Okay. In fact, the latter is actually 1/3, okay, of the former capacity. So another way of quoting battery capacity is in kilowatt hour. Okay, but that usually uh, used for larger application. For example, big aircraft with hybrid propulsion system, they use kilowatt hour. But for hobby UAV, small UAV, it's more convenient to quote in milliampere hour. Okay, because it's easy. You imagine you just you cruise the aircraft with the voltage fix, and you just measure the current that is consumed. So from there, you know how many hours, okay, you can go. Now, back to the kilowatt hour. 1 kilowatt hour means it's 1,000 voltage ampere hour or 1 kVA hour. Okay. Now, okay, sorry lah, batuk. Okay. For example, a 12 volt battery with 5 ampere hour capacity, okay, is equal to actually 60 watt hour energy. Okay. Yeah. it actually contains 60 watt hour. Okay. This may not be important for you lah in the test and exam, so because it's not inside the standard syllabus. But since we know that electric vehicle or electric aircraft, especially unmanned aerial vehicles and drones, are the future. Not the future; it's already here now. Okay, it's already in place. So I think it's better for you to also understand this. Okay, and I will explain further in the tutorial session later. Okay, I think that's it for now. Okay, see you again.